With great data comes even greater access latency. Welcome to the Trino Community Broadcast, where we transform your latency woes into fast insights. Trino Community Broadcast is a show where we cover events and happenings in the Trino open source community and show off a couple cool things about Trino. So today, I'm really super excited to talk about our guests. We have Ryan Blue, the creator of Apache Iceberg, and Sam Redai, the developer advocate from Tabular, which is the company that builds on top of the open source Apache Iceberg. Welcome, you two. And we also have for host today myself, Cole Bowden, who is another developer advocate here at Starburst with me. And then we have Tom Natz, who is, Tom, what is your official title?
Janitor, but sometimes I'm called Director of Customer Solutions.
That's true. Okay. Yeah. I forgot the janitor side gig you had going on. So tell us, Ryan or Sam, whoever wants to jump in on this one, what's Tabular doing around Apache Iceberg, and what are you all kind of, what are we kind of here to talk about today a little bit with Apache Iceberg?
Well, I think we're going to cover some of the development in Iceberg that has been going on recently, sort of where we are going with the community. But I'm always happy to talk about Tabular as well. So Tabular is the company Sam and I work for. Basically, we started Tabular to build and make available all of the infrastructure that you need in order to run a modern Iceberg-based data platform, that can connect to any engine that you want to use with your data. So you can plug in Trino, you can plug in Spark, you can plug in, EMR and Flink and Snowflake, whatever you need to do. All of the infrastructure required, like the common catalog, the authorization and access control layer, data services to keep your tables clean and performant. Those runtime services are all provided by Tabular, and we make it pretty easy to plug in.
Very cool. And Sam, how did so you're a fellow developer advocate like me and Cole. How did you get involved with Ryan, and how did you two meet, and what got you into Iceberg?
Yeah, so me and Ryan worked together at Netflix, and it started with me one, I took the class where sort of intros, like I think it was called 101, Iceberg 101, I think, and I've came from sort of a Hive background working with, I think the Hortonworks is what we were using before. So, I was very familiar with like using Hive tables and Hive-like table formats. And then when I saw the sort of what Iceberg could do and, like the idea of snapshotting and committing and sort of those Git semantics for massive tables, and then actually saw it, applied to large tables, I was like a fan right away. And so, I worked on some of the tooling stuff around Iceberg that sort of utilizes Iceberg, which I think we'll talk a bit about today. But, I started bugging Ryan about little things here and there. And then as I sort of built out these tools, I got very familiar with the internals of Iceberg. So that's sort of the background. And then, Tabular, I saw that, and the rest is history.
Nice. So you were like, I gotta get on this thing while I can. I'm so sorry, Netflix, but we gotta build out the greater community of Iceberg. So I want to quickly share something we shared in one of so we did a couple episodes around Iceberg way back in not way back, but I mean, at least a little over a year ago now, in April of 2021. And so the very first episode we actually did with David Phillips. He was very heavily involved with Iceberg. And so the first Iceberg that we created with our little logo with Commander Bun Bun dressed up as a penguin standing on an iceberg. This iceberg actually was not going to be super good for Commander Bun Bun to be stepping on. We found this out through a friend of ours who watched the episode and said, that's actually not correct way that an iceberg would actually float if it was drawn this way. So I wanted to quickly go over, if the iceberg was actually drawn the way that we had initially drawn it, here's what would happen to Commander Bun Bun. He's sitting up here on the top, and he would fall off onto the side. So we realized actually that we should have done what we did in the second episode and what we pulled in here today, where we actually drew the correct, I don't know what you say, if it's like the correct balanced or actual correct way that you see icebergs in nature. But if you actually look at how these kind of flat tabletop looking things, and you actually draw it out that way, it actually is keeps Commander Bun Bun on the top of it. So yeah.
Fun fact is that that's why we chose Iceberg. There's the connection is these icebergs are called tabular icebergs because they're flat like a table on top. So the connection is tabular iceberg, and then we stole that idea for Tabular, the company, as well. So that's why we call Tabular.
And does it also keep your data afloat? Like, is there some sort of, have you tried to pull some sort of metaphor there?
Oh, there is definitely a metaphor there about like, you only touch this much of your data, but there's a lot of it.
Yeah. Awesome. Well, without further ado, why don't we before we hop right into the cool, amazing things going on in this, the table format and Iceberg and everything. Let's jump really fast, and I'm gonna bring this over to Cole. Cole, we've had 2 releases since our last episode. Would you want to tell us a little bit about? Here, let me actually zoom in here a little bit so that we can actually read this. What's going on in Trino world in general, and then we'll hop into the Iceberg stuff here in a second.
Yeah, so we've had some pretty big performance improvements across the board in the core engine. We've got some new functionality in forms of JSON output for explain. Like expressions are faster, insert queries are faster, large clusters are going faster. Aggregations have less memory usage, fault-tolerant execution has less memory usage. So
nice.
Trino across the board improving in big ways. Some extensions to a few of these connectors. The 2 that I think are the most exciting from these 2 releases, that faster insert queries bullet point is a huge one. We're going to talk about it a little more later on as well, but from the tests that we've been running, it is on the scale of 6 times faster or 4 times faster. It may not be exactly that much faster in like production inserts, and it kind of depends on the scale. You're going to get more of a win the bigger it is. But anytime you can say something's getting 2 or 4 or 6 times faster, like that gets some exclamation marks and confetti and stuff.
Yeah,
so,
yeah, for sure.
And that actually affects Iceberg specifically. So,
and we're gonna discuss a little bit more into that on the PR of the week here. So look forward to that in the PR of the week that we'll dive into.
And then the other really cool thing that came out is that we have support for dynamic function resolution in the SPI. So Trino plugins now will be able to have dynamic function resolution, and that is going to make plugins a whole lot more interesting and powerful. That's going to open up a lot of opportunities. So Trino plugins now have a lot more power within their grasp, and it'll be interesting to see what the community is able to create on that front.
I'm a little, so dynamic function resolution, you can actually kind of set register a query at runtime or something like that. Is that what that's saying, or is that?
Yeah, I think it's that the plugin can handle and resolve like functions that it wants to implement within the query.
Gotcha.
So you can do new functions from a plugin.
So this is at the core. This is actually in the core support for it, and then connectors just we haven't really had any connectors take advantage of this yet. It's just that it's available to start taking that.
This is okay. It is now possible to do this in your plugins, and now let's see what we do.
Yeah. It's the same thing when PTF came around, which actually polymorphic table functions, when that first came around, we actually co-released the core support and a cool feature with it, so it was somewhat tangible to what this could mean. But yeah, I think dynamic functions is pretty clear. We'll be able to actually not have to I think the more and more Trino is adding a lot of this support in general for ability to do things during runtime, and that's just a lot of cool stuff. Particularly this is pie in the sky at this point, but we're getting closer to this of dynamically adding catalogs to Trino. So if you want to add a secondary or third catalog to say a different database or things like that, you don't have to restart the entire cluster to do that, which is a rare thing to have to do. So it's not super in your way, but it's just that's yet another thing that you don't have to restart Trino to get that. And so dynamic function is another thing on that path. That's exciting.
Yeah, I know we're working towards the dynamic catalog manipulation. So
Yeah, one day.
one day, give it a year, give it 2 years. Who knows? It might
Cool.
even be less than that, I think.
Yeah, I'm very bullish about it becoming in the less than a year.
Yeah, I think that's probably right. Anyway, so that's it for the updates. You can always check out the release notes. I work on them diligently for all of your sake.
Yes.
So.
Yeah. Oh, and so so everybody knows, like, Cole is kind of a partial developer advocate, but then his other title here is release manager. So so anything that we're going through when it comes to these releases, Cole touches everything now. so
I see all. I look at every single commit and make sure that if it's user facing, we get a release note.
You're like that eye in the Lord of the Rings.
Yeah, except like instead of being the evil demon lord of power, I'm just like a guy trying his best to communicate things. So
yeah, but is that what the evil Lord of Power would tell us? Anyways, all right. Well, enough chitter chatter. On to the concept of the week. All right. So this concept of the week, we're going to be talking about the latest features in Apache Iceberg, and also then cover a little bit about like what the Trino community has been doing on our side in the last year to kind of take advantage of some of the latest things coming in. So so these are the notes for that. You'll be able to find all the kind of summaries of what we're going to talk about in the show notes. But for right now, I will remove that. And I kind of want to just open this back up. Now we've talked a little bit about Tabular, but and we've had 2 past episodes where we did dive into like what is Iceberg and why is it such a big deal. So if you aren't familiar with that, the link to those 2 previous shows, it's episode 14 and 15. Definitely check those out if you're totally like brand new to Iceberg. But in a kind of a couple sentences and kind of like maybe you could get a little philosophical with this, Ryan, but like what is Iceberg and what are you trying to solve with Iceberg? Like, take us through that mindset and like the use cases that you're going for solving there.
Yeah, so Iceberg is a way of tracking data in a table. It's kind of like a file format, only we realized, I was early on in the Parquet community, and we realized that a lot of problems that people had were not file format problems. They were really this broader thing. Like, how do we keep track of what files are even in a table? How do we know which files to read at any given time? How do we make changes to that set of files in a table? And the answers to those questions are surprisingly core to what Trino and other big data engines do.
Yeah.
They define how you can make modifications to the table efficiently. So like that has a massive implication on what you can do for users. Like, we're going to talk about merge statements later. That is, that would never be possible without good answers to like, how do we modify the files in the table?
Yeah.
Also, like, all of the powerful advanced filtering features and things like that really matter. When you're talking about like, query performance. How do we find exactly which files we need to satisfy some query? So Iceberg handles all of those concerns. We built it because we realized that this table level was very naively put together in Hive and Hive-like tables.
Yeah.
And we realized that was limiting correctness in our platform because we didn't have atomic transactions or atomic changes to our data. We realized it was really limiting performance because we were basically listing thousands of directories and then just reading all those data files instead of pinpointing the data that we needed. And then we also realized that the biggest factor was we were limiting the productivity of data engineers and people consuming data because they had so many concerns that had to be constantly on their minds. What is the partitioning of this table? How do I take advantage of that? What are the implications for how I write? Like, they had so many concerns that we wanted to get back to a point where you kind of forget what's underneath the table and you work with data as a data engineer, which sounds crazy.
Yeah.
But you should think about data and data products and pipelines a whole lot less than you care about the number of files you're producing or whatever those underlying characteristics. We wanted to bring that abstraction back.
I like that talk that you give. That's just, why should you not care about Iceberg? It's hilarious the way that you poised that. What, if you can, take that the takeaways from that talk, why shouldn't you care about Iceberg?
Because it's a table. Like Iceberg should give you this logical way of working with data, and you should not care about how often do you care how Postgres is dividing your data up into files?
Yeah.
Like, have you ever cared? Why do we have transactional databases where you don't care underneath the file level? And in the big data world, you have to care very deeply about the size of your data files. It's ridiculous.
Yeah.
So, that's our long-term vision for Iceberg and for Tabular, is building this system where the database gets smarter and smarter and takes on more workloads in order to free up, mind share for doing the important work of a data engineer. Not thinking, oh, is Spark going to barf on this?
Yeah. You mentioned, that this you're trying to take this approach versus like the Hive-like kind of approach to building out a system like this. So what's the Hive-like approach, and what does that look like as opposed to, what you all are doing? And what do you mean when you say Hive-like?
So Hive-like tables were basically unplanned, I would say.
Okay.
We built a directory structure, and then we said, okay, now how do we navigate within this directory structure to pick the files that we need? And there were some band-aids on top of that, but that was basically what you got. And the directory structure, the directory names became columns in your data set. And you constantly had to work with those columns, the partitions, and care very deeply about what you're selecting there.
Yeah.
And that gets a little ridiculous. So if you're trying to write data into a table by, event time, but then you're actually storing it in these directories by processing time, you have to both select your event time window, which is event timestamp greater than 10 a.m. today, and then you have to think, okay, when were these records actually landed and processed? And I guess that could be any time after, or given clock skew, processing time after and you have to select entire directories and then scan through all the data in those directories. You're caring about what is underneath that table way more than you should. So that's one problem with Hive-like tables. They also, a hallmark of Hive-like tables is relying on names in CSV files or JSON files or Parquet files to do column resolution. So you get odd behavior, drop column foo, add column foo, and then you get all the data that you just dropped.
Yeah.
We call it zombie data.
Yeah.
You don't want zombie data because you probably don't drop a column and re-add it immediately. But there are situations, and we've seen this, where someone drops a column because they wrote bad data into it. And then someone a couple of years later is like, why isn't there this column? And they add one and start filling it with data. And then they realize that aggregations have data from, bad data from 3 years ago that they didn't know existed.
Yeah.
That zombie data thing should probably just not happen.
Yeah. So essentially, Hive-like kind of systems are kind of not they were built with the premise and too heavily relying on the premise that Hive set for big data systems, and essentially there's they don't really act. They have a couple things that maybe somewhat mimic it here and there, and they've made some iterations, but it's more like these things have largely not been able to stand up to become equivalent to something that you would expect in Postgres or other databases.
That's exactly right. They're not real database tables because you have this, inherent view into their internals, and their internals are constantly exposed to you, right? You have to know, oh, this table does resolution by name or position or whatever. And that dictates like how your schema evolution on that table works. Like whether you get zombie data or whether you don't, whether you can rename or you get 2 columns and like weird stuff. And so like exposing the internals of a table because we didn't really build the table abstraction correctly is, I think, the main problem. So when we built Iceberg, we decided to basically fix and restore that table abstraction. Now I'm using like the way I currently think about it, because it was like a couple years later that I realized, oh, we just restored like SQL behavior. But like that's essentially what Iceberg did. We said, we're changing this, we're making a breaking change, let's fix all these problems and really make it so people don't need to care anymore.
Yeah, that's I mean, I think that's deep. And so does that kind of get down to the like philosophy of like, why you built the spec and why, because so essentially there's a spec about how is that data stored? What's the ways that we can kind of interop? Like that's not necessarily something that we would see in a traditional database, right? It's like now we're actually trying to branch out of like using a singular system. Could you talk a little bit about like the goals there in the like Iceberg philosophy?
Yeah, so the spec was written out of pure selfishness. That was because I was the guy integrating Iceberg into Spark, and we basically said this is a ton of work, and we wanted to build not just our own table format at Netflix that solved our challenges, but we wanted to build something that other people could use. And that could be built into any database or big data processing system. And so we knew that in order to do that, having sort of tribal knowledge about how this works, another sort of hallmark of the Hive-like formats, like, oh yeah, it's __ Hive default partition __ null value in your partition. Like, what? We wanted to make sure that you would have compatibility and that engines could build on top of this work that we'd done, primarily so I didn't have to implement this in any other engine, which is sort of now paying off, where you've got Snowflake and Dremio and other engines like Flink that are being contributed to and working with Iceberg.
Yep. Yeah. And so I know there's still sometimes, when engines first come in, there's still at occasion, like something that there's so many potential areas where you have to standardize on. And it's like the spec has just grown intensively to meet a lot of those needs over the years. But I remember like in the early days, whenever Iceberg was first officially released in Trino, like there were just still so many, like if there was something that was written by Spark, it was still really hard to get that working. And I feel like the experience now, like getting newer engines in, like what was the one that just Star Rocks or what's the one behind that?
What's Doris?
Yeah.
Like there are a number of them.
Yeah, so like I've seen that like they haven't had as big of an issue kind of getting integrated, because I feel like now that we've had at least 2 or 3 different engines, especially with different types of use cases, it's been like a very different experience probably for even the newer engines that are coming in now. And that's just going to be the case like kind of moving forward. Like it's just once you've kind of dealt with a lot of the kind of overlapping I think about it like just the Venn diagram, it's just so much easier to put more on top of it and make sure that you get into the circle. So I mean, I think that that's kind of one of the biggest things for me that like I see that differentiates Iceberg from any other kind of table format out there, is like the pure ability to just like look at a spec, know exactly, not exactly, but for the most part, see essentially like learning from the previous query engines and how they did it, how you're supposed to basically fall in on this format, and then go. It's like it's not like the easiest thing in the world to write that kind of integration overnight, but it's still something that now is just way more approachable, and it's only going to bring in a lot more future query engine and drive a lot more innovation around this around Iceberg particularly.
Yeah, and I'm really excited about that sort of thing. We're also building a Python implementation that I think we're working on a release hopefully this week with a CLI that can work with the REST catalogs and explore things, show you table metadata. It's not quite there yet, but I'm really excited about being able to have this interoperability between the Python world and where it's totally normal to be like, go fetch this data in 1,000 different processes and train some ML model with slightly different parameters.
Yeah,
like, being able to share tables with those use cases and powerful engines like Trino, that is a really powerful data architecture.
Yeah. It brings it out to not just data engineers working in directly with Iceberg anymore. It brings the data scientist or even anybody who kind of works in that Pythonic, kind of language or kind of approach where they're using, I don't know, pandas and all that stuff. Being able to have a quick way to essentially just load that data through, into like a pandas data frame, and to have all that power that the pandas, tool set or all the ML libraries that sit on there. Yeah, it's extreme. Like, it just lowers the barrier a lot for anybody that's even outside of the data engineering sphere. And it kind of, now it's, what's interesting about this is like, there's all this talk, that's been happening the last 5 years about like data scientists being like, oh, well, now I'm becoming kind of more of a data engineer. But it's like, what was being a data engineer 10 years ago is just very widely different from what data engineering is today. Because now you could actually do a lot more with SQL and Python than you could in the early days of Hadoop. So yeah. And Iceberg is, I mean, in the early days of Hadoop, you had to literally, do Java code programming and MapReduce programming to be able to even touch this stuff. But now it's like, we're just worlds away from that, being able to now everything is available in Python and SQL. So it's crazy what that's enabling. I don't know. So I think like that flexibility that this gives users is huge. And I think that is primarily the big reason why I think a lot of people are getting excited around Iceberg. So
yeah, just the choice of being able to use any processing engine, and not, I mean, you could do that before. You just had to forklift data, right?
Yeah.
You had to be like, okay, well, now I'm going to write a job to go, read from this place and write it into this other format because this thing can use it. Like, hopefully that just goes away. And, we have like independent central data stores that are accessed by any number of different engines. I'm really excited about that world.
Yeah, we've seen a lot of these use cases being asked, like, so internally at Starburst, more and more people are asking about Iceberg. Tom, you have a lot of experience in this kind of realm of like, the different people that have been kind of trying to figure these things out. Like, what kind of use cases have you seen brought up from Starburst side that kind of is people are asking about? Because I feel like that these aren't just like, oh, like Brian and Sam are just kind of coming up with these things off the top of their heads. Like, these are very much like sought after use cases that we've seen even, from just like starting from the Trino query engine and moving into, whatever their particular use cases are.
Yeah, I think I've been actually really surprised in the last about 3 or 4 months. I've seen this huge rise in interest in Iceberg, and I work on mostly our Galaxy, which is our SaaS product. So it's a hosted Trino version. So I talked to a lot of prospects from, large enterprise to mid-level companies. And I think the biggest thing there is that the promise of this whole data lake and then migration to a lake house is the majority of the people I'm talking to, they're landing data already into some kind of object store. And then they provide that up and they provide that data to like data scientists. It's still kind of in a raw state. And then there's still this concept where I did data warehousing for years. I still need to get this into like a data warehouse. I need to be able to I need to enrich this data. I need to join it, and I need to create rollups and aggregations and then provide this out to a bunch of my BI reporting people. And in the mindset in what's happening in the industry right now still is I need to get it to I'm not going to name names, right? But it's a cloud data warehouse, right? I need to get that. And when I talk to these people, and it's usually, well, let me just show you, like, look at this, create table, roll up weekly sales, select star, and then format equals iceberg. And I never even thought about that. And just, you could see their mind shift in their head, like, and then I show my diagram that shows all, like the 3 layers, right? Land it and then enrich it and presentation. And I'm like, you could just do that right on top of your storage. And they're like, and you can see the little wheels turn. It's like, I don't need to separate my data. And it's not, sometimes it's about cost. Sometimes it's about, now I have data that's landed here and now I have it over here. It's 2 systems I have to maintain. Why can't I just have one system? And I came up with this little diagram here. Let's see if I can get my screen to share.
Yeah, I'll pull it up.
Here. Can you see that?
Yep.
Yeah, so I've been trying to go through and look at all the different engines that support the Iceberg API. And obviously, my world is over here, our world is over here in Trino. But I was surprised by, a lot of these different engines out there. I call them engines, right? And, when you see Snowflake dipping into this, that, Ryan must have just not slept that night because, you have the big gorilla in the room going, hey, no, this is a valid table format. We're going to support it.
Yep.
I'm so surprised by it. But it just shows you that this is it. So when I talk to people, like, don't you want this as your vision? You own this data. This is your data. It's in your account. Look at what Iceberg gives you. It gives you database functionality that you've been asking for years when they sold you on Hadoop, right? And they go, yeah, you can't modify the data. It's really slow. You have to add a bunch of columns just to do the partitioning. And then you have to teach your users that they always have to include those 3 columns that they don't really know what they're for, but they have to be in those queries. Otherwise, I'm going to kill your query. And then obviously there's time travel in here as well. So don't you want to be able to offer this and then pick and choose your engine? And the way I pitch it to people is say, like, for me, Starburst, like, we have to continue to win your business month by month. Otherwise, you just go pick one of these other engines. Or if there's one of these engines that are not, or somebody comes by, right? Brian's engine comes along and it supports Iceberg and it does this really cool whatever, right? Something to do with data science or something like that. Here's your data. You're ready to go. And I think this is the most exciting thing I've seen doing this for 25 plus years now, that, and I explain it to people, like, imagine Oracle, open up their engine, 20 years ago, that anybody can come by and interact with their storage or something like that. That would be unheard of. Now we're at this point where that is heard of. Like, you can do this. And this is what the excitement is for a neutral API that's out there, that you could just bring your own engine. And these things come and go, right? I'm hoping that we'll be here for a long time, but these things come and go. This, next year, there'll probably be 5 or 6 added onto this. This is going to get very, very busy. That's what
there's already a couple missing.
So, oh yeah, let me know what they are.
I'll send it your way.
BigQuery and Apache Doris and StarRox.
Okay,
So, BigQuery is a pretty big one.
BigQuery is another big one. Yeah.
So BigQuery does now too. Okay.
Well, I think it hasn't been released, but there's an article where they mention adding Iceberg support. So.
And then what's the Fivetran? I heard Q4 will be out as well.
Nice.
So it's just growing and growing. And when I talk to people, it's like, where do you see yourself in 2 or 3 years? Having this architecture where you can kind of pick and choose what you want, or you just want to be in some, I call Oracle on the cloud, right? You want to just be stuck in somewhere. There's no difference. And that's great. If you want to do that. And when I've talked to some companies, they're like, we don't care. Well, this is great. I'm like, okay, that's great. And I'll check back with you in a while. So it's pretty exciting times right now.
Yeah. Yeah. Thanks. I knew Tom was going to nail the excitement around it that we all are feeling about it. But yeah, I mean, that's like why you should choose Iceberg in a nutshell. So I mean, anything, Sam or Ryan, do you have anything, other comments that you have on that, or even Cole, if you had any thoughts there?
Yeah, I would say for me, the interoperability, that's the main story. I mean, Ryan talked about sort of Hive-like tables exposing the internals, right? Yeah. And what I've seen from that is, you can do things like versioning your table, and every data engineer has their own mechanism for versioning their table and has their own mechanism for, optimizing queries. And it really makes interoperability across different engines very difficult, right? And so with Iceberg, I think the spec, having that spec that clearly outlines it, that every engine looks to and implements, it allows not just, you can write the data in one engine and query it in another, but all of those core Iceberg features like rolling back snapshots, like time traveling, are all available across, other engines, and the behaviors are the same. So the conversations that I see, it's less about, oh, I can do this in this particular engine, but people talk about the table as a concept, right? They talk about, hey, have you looked at the table snapshots? Have you rolled back? And this is without even knowing necessarily what engine that they're using. Is you're talking about Iceberg tables. The conversation is around tables, right? The techniques and everything. So that I think is a big part of it.
Yeah, and in supporting database type transactions and things like that, and all those capabilities, the one thing that has lingered around from Hive that we've all desperately wanted to kill is the Hive Metastore, and so Hive Metastore is like one of those things you love and you love to hate, and so it's like been able to give us a lot of the initial interoperability and a good migration story from a lot of people who are starting from Hive and moving into Iceberg. But it's never been one of these like, fun services to run yourself, and also just like very confusing, especially just the same way that a lot of stuff with Hive was a little confusing in terms of like, having things like the Thrift API to deal with or things like that. So what's going on in the Iceberg community, that's kind of looking to address that, and I want to preface anybody in the Trino community, we're going to use this word that we use in the Trino community in a whole different context. So there's this thing called, and we like to call them metadata catalogs, because that differentiates them from the catalogs that we typically are talking about. So catalogs in Trino land is, we're talking about different systems that we're connecting to, because we connect to multiple things like Iceberg as well as Postgres or any other kind of Elasticsearch, what have you. So that's what in a Trino land, that's what a catalog is. Now in Iceberg land, you all just call them catalogs as well. So just wanted to be very clear, when we're talking about catalogs in Iceberg land, we're talking about what we like to call metadata catalogs, which is how a catalog, or essentially a way to store all of the metadata across. So could you talk a little bit about like what a metadata catalog has to support, and what variations there are, and what you all are doing in kind of the Iceberg community to kind of think through the next generation of what that looks like?
Yeah, absolutely. So the catalog area is kind of funny. And like you say, like you would normally think of like an Iceberg catalog or something where you can talk to this thing that tracks Iceberg tables. But Iceberg actually has many different catalogs. You can use Dynamo, you can use the Hive Metastore, you can use Glue, Tabular, and a number of very different things. And that was because at the time, no one could agree on what the successor to the Hive Metastore was. So we needed to make it pluggable so that you could use whatever you chose to. But what we found is that proliferation of like catalog implementations or Metastore catalog implementations got pretty messy. Yeah. So like, yes, you can just hook up a JDBC table and send your catalog information to an RDS, and everyone's happy. The problem then is you've got to get that jar for your catalog implementation into Trino and into Spark and into things like Dremio, and like where it's kind of harder to drop in a jar with your own logic. Mm-hmm. Right. So, Starburst Galaxy is another great example. Like if I came to Starburst Galaxy and was like, hey, I really want to use Starburst Galaxy, but I need to drop this jar into your hosted infrastructure, you'd be like, go away, you're crazy. Right? Yeah, let's do that. So what we've been working on lately is sort of akin to the Thrift API for Hive Metastore, only like the Thrift API was like internal communications channel that eventually became this thing that everyone said, all right, well, we can just implement that Thrift server and make it look like you're talking to the Hive Metastore. We're actually defining a REST-based specification for a Metastore and how you interact with that Metastore. to replace that thrift API, because that's really where the compatibility comes from. So we can drop a REST catalog connector into Trino, and you can talk with any custom Metastore backend, right? And we can do that same thing and basically all agree on how to talk to a Metastore for Iceberg tables.
Got it.
That makes this really clean, because that's something that we can drop into Starburst Galaxy, so that Starburst Galaxy can talk to basically anything. And then we also have an adapter so that you can run your own HTTP service that, you know, talks to your JDBC backend or whatever. And what I'm actually really excited about is this cleans up some of the ugly areas of the catalog API as well. So when we were trying to go for this like lowest common denominator, you can plug in your own catalog thing, we made it so that every commit basically swaps the metadata file. And so like any change to the table metadata could conflict with any other change. Well, in the REST spec, we're making it diff based. So two clients will send changes like add this column to a schema and add this snapshot and set the current snapshot. And those two things have nothing to do with one another. So both can succeed from the client's perspective. So we have fewer retries and we have fewer commit conflicts, and basically everything operates faster and with fewer rewritten data files. So we're really excited about not only the connectivity that this brings, but also the ability to just make progress on some of those fundamental challenges and make the commits a bit better.
Interesting. What that's the, I think that in the grand scheme of like how we actually would be able to approach this, I don't see any other way that like you can get everybody to agree without coming up with yet another kind of spec or way to kind of, so how do we actually, so have you found any issues like getting into getting the actual REST API and all that stuff agreed upon, or is that primarily just a couple like maintainers and maybe a couple interested, I don't know, people that are really interested in developing this feature? Are they kind of providing a lot of the feedback, or how do you even then determine the one catalog to rule them all, I guess?
Well, so it's not one catalog to rule them all. This is really just an option for talking to catalogs.
Okay.
And you can adapt the old catalog jar API, right, into this. So we think that that's really going to help. But, a lot of the interest here is from companies like Netflix and Apple and others that run their own catalogs. Right. And they have never been able to, use services like Starburst Galaxy because you're not going to drop Netflix's catalog jar in there. So it opens up this world of, compatibility. So I think that that's really going to drive the adoption.
Gotcha. Yeah, where one catalog could exist at both Netflix and Apple, and yet they're still using their custom, version that they've worked on for years or had like 5 different iterations of. However they want to do it, it's like they basically get that freedom to use whatever they're using internally for their Metastore, and then now it's still falling under the same API. That's really
exactly
cool.
And they could just stand up a simple microservice that fronts their catalog jar that translates and does this. So it's actually really simple to set up. And then you have that connectivity.
Nice. Another interesting kind of cool feature that I haven't, this one just like falls totally outside of the whole spectrum of maybe what you would expect in a database, but this is starting to become a very trendy thing in like the whole big data world in terms of how we're trying to get, this whole concept of like data lineage and things like that. But Sam, could you tell us a little bit about kind of like maybe we essentially Iceberg's built on these things called snapshots. We've talked about that before, and you could kind of make the analogy that snapshots kind of work like commits in like Git, and thinking about this, like traditionally when you think about databases, you think about a very just one linear write ahead log, and then like that gets committed to the actual persistent database. and that's the end of the story there. But now with big data and the way that we're kind of modeling this data, and it's a very transparent thing, you're actually able to interact with these kind of snapshots. We kind of are enabled to kind of have a Git-like capability around like how we version our data. And so could you talk a little bit about like what features may be coming out and what you all are doing around that space in terms of support for that?
Yeah, so I think the analogy to Git commits is a good one. It's a common one that's used, right? The snapshots are, I mean, commit is a terminology used in Iceberg in the source code, but there's a couple of big features that are coming up are branching and tagging, which has been accepted and added to the spec. So it's included now in the official specification, and the implementation is in progress now. A big use case for that is integrated audits, or what's called write audit publish, and it really allows you to take like I think you described it well. Is traditionally we just think of a table as like a linear object, and changes are made, and there's this one current state of the table.
Yeah.
And with Iceberg and the rich metadata and the concept of snapshotting, you can do some pretty cool things there. And what write audit publish does, it allows you to sort of stage snapshots.
Mm-hmm.
So instead of just inserting data and the current state of the table changes, you can actually stage that data, and it gives you this buffer area where you can run audits against it, right?
Yeah.
And that's all done without branching and tagging, right? So today it uses a cherry pick, which actually works really well. And it's the scale doesn't matter too. It scales with Iceberg, so you can actually perform these, stage these commits and audit with very, very large tables.
What we want to be clear too is that these are actually our only current. We haven't supported this yet in Trino, but so everything that Sam's about to tell all of you, get excited. We'll probably eventually support it, and if you want something like this, let us know. But we currently you have to do all this through Spark, correct?
That's right. Yeah. So it's the actual mechanisms are there in the core library, but Spark is the main engine that's implemented it.
Okay.
With branching and tagging, though, that I think will bring sort of a new element that'll make the pattern even more powerful. And so, I think the roadmap for branching and tagging, and once that's available in Spark and Trino, that'll be a much more powerful mechanism to use this pattern. If I could just talk quick about that. So like right now with the whole concept of cherry picking, it works really well for a sort of a traditional, batch workflow, ETL, right?
Mm-hmm.
You stage some data, it runs daily, for example, and you want to run some automated audits. Where it starts to get tricky is if you're doing sort of long running changes, or you want to, I think a common use case is you have a couple versions of your table that you run in parallel. It's a common ML case. You're running different experiments, and you run it for weeks, potentially months. And what branching allows you to do, once it's implemented, it'll allow you to branch to a different sort of named reference for the table. And you can write to that as if it's the current head of the table, and you can do anything. You can do schema changes, you can do appends, deletes, and merging that branch in or bringing it back to the current head is just a metadata operation as well. So it makes it a bit more powerful and more robust. And so when you have like large concurrent writes across, sometimes writing to the same partition multiple times, those are things that the current model, can do, but is a bit tricky. And branching and tagging will clean a lot of that up.
Yeah. I think in general, just having even the ability to alias a snapshot, with something that's like, every day, let's say you cut, you're calling like at this time, I'm going to set up an automated way to start tagging this at the day or hour or what have you. And you want to basically be able to do rollbacks to all these different times and have a name for that, so that when you essentially do select all from this named thing, it's just so much cleaner and clearer. And once everybody understands some, spec that you set up that you have on that to actually identify that whatever that snapshot is, then everybody's talking to the same snapshot. It's in human language. It's not in, 135. I mean, you'll see that here in the demo shortly of
Yeah,
addressing things directly.
Actually, so in the last community sync this week, someone brought up a great use case, it's very similar to that, and it was around compaction, right? Is that you can sort of tag a point in the data where data is compacted up until this point, and then users, your data scientists or whoever else are sort of consuming the data can just query at the tag, right? So it gives you sort of those capabilities as well. So yeah, there's tons of way. I'm excited for this feature in particular. It's there are a lot of great things that you can do.
Yeah, it's going to be huge, and I think that people will always. Communities always surprise me in terms of how they figure out different ways to use something that gets released in the wild. And this is what we like to do, is releasing some of these kind of features, like core capabilities, without actually diving too heavy into what this could mean, and then people just keep surprising us in terms of the ideas that they come up with, how the applications that can go from there. So it's always really fun to see those things happen. Another cool thing that in terms of how community brings up really interesting things, I actually want to take a moment to brag on Piotr Findason, who is one of our long-term Trino contributors. He brought up an interesting use case that we'll dive into in a little bit. It's one of the kind of examples of things that change in Trino Iceberg connector, actually in this last release. But we were trying to basically do this analyze statement, and analyze gives you this ability to build up statistics and stuff like that, so that when you're running the query, essentially building the query plan, you can have better statistics to work with to essentially build the query and run it more optimally. And some of those stats exist at a table level, but other stats dive in and live at a more granular level. So Sam, could you kind of dive in and talk a little bit more about this kind of new format that we're looking into, that it's particularly not to be confused with table format. This is a new file format that we're looking to replace something on the lines of Orc and Parquet.
Yeah, so Puffin is the name for it, which I really like the name. But the big thing here is that the Puffin format, it's an official spec, so you can see it is published on the Iceberg doc site, and it really couples sort of these stats and indexes to individual Iceberg tables. So all engines can eventually sort of take advantage of them, which is in line with the theme of Iceberg, right? It's that it's consistent, reliable interoperability, across different engines. And the first, Piotr was really the one driving kind of the first use case here. So it's out there with, it uses sketches. So, sketches, one of the other terms for stochastic streaming algorithms. It sort of processes a stream of data, and you can provide approximations. And then using those approximations, you can sort of speed up the query on orders of magnitude faster than exact methods. So it has all of this is specified there in terms of how these blob types work and how you can define them. And so the idea here is, as the format as this format grows over time, that it can be a place for engines to sort of speak the same language when it comes to statistics and indexes and all the other things that are used during query planning.
Nice. Yeah. So how does Parquet and Orc, they have also kind of file level statistics. Is there, what's the big advantage that Puffin's bringing outside of from a what it's actually storing, or I know there's some things relation to Iceberg. So is this Iceberg specific? And it's something you would have to be following the larger Iceberg spec in order to be able to use Puffin, or could Puffin be used outside, technically in Delta Lake or something like that?
So Puffin could be used in Delta Lake. The purpose of the format is to basically hold these sketch blobs so that you can do incremental work. The initial use case is counting the distinct values for a column and producing a sketch for that. And that's really important when it comes to join reordering and planning within Trino and other engines. So knowing, hey, I'm going to get 6 different values versus 6,000 different values, right?
Yeah.
You can tell if you're feeding that into a join, that's really important.
Yeah. Yeah. Yeah.
Now,
Huge.
so what you want to do though is not read the entire table to produce that estimate every single time.
Yeah.
So what you want to do is read the table once, produce a sketch, and then incrementally update that sketch. And so that's kind of what the Puffin format is intended to do. It holds those sketches, which could be really big. We're going to be using it for indexes coming up as well. So think like a Bloom filter index.
Cool.
Well, a Bloom filter, you need 1 byte per unique data value. So if you have, 1 million unique data values in a given partition, that needs to be a megabyte large. And that's just way too big to fit in like an Avro or Parquet or ORC format.
Gotcha.
Those things are really built for row level data where you have like 8 byte values instead of 1 million byte values.
Got it. Super cool. And so when would, I mean, what's the plan? Or I guess kind of, we already have the spec kind of going. Is there any plans around like how Puffin's going to come to light, or is it? I guess it's kind of starting with Trino, and what are the conversations going on around like Puffin right now in terms of when or what or next steps?
Well, we're working on getting the metadata tracking, like to identify Puffin files and link them to Iceberg metadata into the Iceberg spec. So like Iceberg's going to have a section of statistics files where you can interact and set a new stats file for some analysis that you did and sort of manage the files. Then we're going to have an API for like, hey, get me the NDV for this column. And that'll say, here's your result. And it may or may not be at that granularity, but that's basically what we're doing. In the meantime, I think the analyzed table just uses table properties, the one that just went into Trino, which is a good workaround. But eventually we want that as part of the Iceberg format so that it's shared and you can run analyze table in Iceberg, in some other engine. Say Tabular does that in the background for you and keeps these analyses up to date.
Gotcha.
Or your secondary indexes keep those up to date, and then all of the consumers of that table can use the information.
Gotcha. Well, there's a lot. I mean, we're hitting close to an hour right now, but there's a lot that we could keep going with. Is there any kind of last thoughts that you all have or want to share, or excitement around the community that you'd like to let everybody on the broadcast know?
I would say keep an eye out for the Python release that's coming out, the 0.1. Faco's the release manager who's been doing a lot of great work and actually contributed the CLI. And he's actually one of the newest committers on the project. So he's going to be a release manager. Look out for that. Everyone, please try it. There's a lot of things that you can do, exploring catalogs, listing tables, sort of that whole area. And we want as much feedback as possible there.
Awesome. And we have links, by the way, to the community segment. So if you need to find out how to, get involved and do all that, you go to community and then just look up Sam. I'm going to just put you out there, Sam, because you're a developer advocate and that's your job. So you just reach out to Sam on Slack, and that's where you'll find him for sure.
Yeah, sounds good.
I'd also love to highlight the REST catalog support that's going into Trino.
Yeah,
I think it's very within hours or days of going in, and that's going to be really awesome because that interoperability story is really happening. That also allows you to use services like Tabular. So we were looking at that that diagram before of all the different compute engines and frameworks and ways of using your data. The one thing at the top was, a central metadata catalog, which is, part of what Tabular provides. And all those engines through the REST catalog are going to be able to talk to Tabular. And so you don't have to run your own Hive Metastore. You'll be able to have real Metastore or catalog features like, hey, if you drop a table, you can just undelete it. Things like that, where, we've never been able to do these in Hive. But they're super important operations. I've accidentally deleted production tables, and that's not a fun day. So yeah, I'm really excited just to have that REST catalog and interoperability there.
Yeah, and that's Dan Weeks is pushing that one, right?
Yeah, exactly.
Yeah, we have a link to that one as well if you're wanting to track that and get your hands on it. Is it something that's pretty, so if you have a Hive Metastore and you have this REST catalog, you would technically be able to put that in front of the Hive Metastore to get, okay. So
Right.
So that would be kind of a first step to kind of playing around if once this thing lands to essentially start branching into using this type of REST catalog.
Yeah. Well, I mean, you can also ask us for a preview of the Tabular platform too, if you want.
Cool.
Yeah. Like, we're already building one as well.
Cool. Yeah, we should definitely, as that stuff kind of comes out too, we should show people how to take advantage of this. And so maybe Sam and I can get some blogs written together on that.
Yeah, sounds good.
Awesome.
And you also already have a container that like you can drop in your catalog jar, and then it acts as a REST catalog for that catalog, right?
Yeah, exactly. So it kind of has like a servlet API. Dan, did a lot of work to put that together. So maybe we can share that, Brian. We can play around with it.
Yeah, that'd be great. I think a lot of people are looking for, kind of a simple starter solution, and we're getting closer to that, especially for new people to both Trino and Iceberg, like that, just having essentially like what we were talking about from the beginning, like a very practically out of the box database, and keeping it as simple as possible. I think that's super exciting. So we definitely will be working on some more around that. While we're talking about things that have come out, I want to quickly highlight pretty much everything that's come out in the last year for the the Iceberg, like Trino connector, I should say, Trino Iceberg connector updates. These are really the big ones that we've are super excited about, that kind of get us to that like out of the box like capability. So back when we talked in like April 2021, Ryan, like this was at a time where we were still like very much the faster read version to Spark. And so the common setup that we saw back then was like Spark was the ingest kind of like, streaming thing, or occasionally it would be Flink, for if they wanted to do more streaming ingestion. And so you would have Spark kind of do a lot of the writing to Iceberg, and then Trino was still not really supporting DML yet, and so you would just have Trino kind of pull out. So if you had somebody that was wanting to use Trino on Iceberg, you really had to have Spark as a kind of sidecar, like a query engine. And so now we're finally getting to this point in the last year, and specifically in just 2 releases ago, we released the merge capability in Trino, and we're going to be demoing this here in a second, so I won't go too heavy into that. But if you don't want to merge, it's essentially kind of similar. You can think about it kind of like a upsert, where you kind of like update and inserting data, and basically trying to make sure that data in a particular criteria will run an update, and if it doesn't exist, essentially you're going to maybe do an insert, or if it does exist under other criteria, you want to delete that data. So it's a very flexible version of kind of like being able to update data, delete data, and potentially insert data, given the different criteria that you send into merge. So it's a very powerful SQL construct that we got in, and it's very popular with Iceberg, since Iceberg does support a lot of this asset transaction capability on this stuff. So it's super exciting that we got this. Also had a couple other create, read, update. We obviously have always had read, but the update, delete and capabilities are also very important to a lot of folks that were needing that support. So update and delete have been around for quite a few releases now. It was quite a bit earlier this year, and those were really exciting. And even some of the things that were introduced in merge are actually going to be coming down as secondary iterations of update and delete that we just didn't have before in the core engine, that will actually optimize some performance there as well. So super exciting that we got all of that in, and so we'll be demoing that. Another big one, we kind of demonstrated back in April, time traveling in terms of like being able to specify snapshots, and we used this at syntax, but it wasn't actually following what other query engines were doing. And we wanted to, again, keeping in the mind of like how a lot of other people's frame of mind is in terms of the syntax they're expecting on Iceberg. We want to try to fall in as similar as possible to other query engines that follow the ANSI SQL syntax. So we did follow in a lot with how Hive has modeled a lot of these this time traveling, and we got the SQL support. So I kind of, it was a little clunky, but we first took the deprecation in 387, and then we introduced introduced this in 386, and we had a fix in 386, 388. And then we deprecated in 387 the at syntax. So just a little bit of things to know. And in general, I'm giving you releases or versions just so you know, but better to just stay on the latest version so you have essentially all of this that I'm listing off here.
Yeah, and to be clear, it now uses the as of syntax like you'd expect.
Yep. And we're working. By the time we release these show notes, Cole's pull request to actually document this time traveling stuff will have landed, and we'll link you all to that and patch that through. So super excited about that. So that you can all kind of take advantage of that. It's a lot cleaner, and we'll show it here in just a second as well in a demo. So then there's partition migration. That was another big one. So Trino is always able to read these partition migrations. So we talk a lot about this in the last episode, in the previous episode. So to find out more about this, you basically, if you are using a partition, you don't have to basically drop what you used to have to do in Hive, drop a whole table and recreate a new one to basically change your partition. Now you can do that in place. And so Trino was able to read these tables if this was done in Spark, but we were not able to actually write and do this ourselves. This was recently changed as well. And so we're able to do that. We'll also be demoing that as well. When Tom was talking about like all of these things that you typically want to do in a database, you want to be able to kind of run optimize, expire different snapshots that are older so that you're maintaining kind of a speed, like all this kind of good housekeeping around kind of your database. These are things that we have also kind of included, and these are the first three. There are a couple other ones that are in route, and so but these were like the top three requested ones, being able to kind of do the equivalent of like vacuum these remove orphan files, and being able to expire these snapshots gives you a lot more performance whenever you're running these types of plans. And then we did, once the V2 support was cinched in, we put a lot of effort in the last, I think, 4 or 5 months, really heavy effort to get up to full V2 support. So we are there now, and it's super exciting. And pretty much every single release, if you look, there's almost some sort of planning push down, avoiding excessive sanding. I want to specifically, in the planning one, this was the one that we were talking about that pushed, for that Piotr was working on, that essentially we're doing a workaround right now, but once the Puffin format is full on, we'll be able to actually have a much more elaborate analyze that is able to take advantage of those file level statistics. So that's super exciting, and being able to take, kind of get those, what did you call them, hints, or they're called, what blobs are called? Not hints, sketches. So to take those sketches and be able to kind of integrate that into the full query planning phase. So it's super exciting stuff that we hopefully will get into in the next couple of months. But there's always some sort of Iceberg thing going out there. So we highly recommend to stay up to date with Trino as much as you possibly can if you're using Iceberg, because there's just constantly there's a lot going on here. And so really excited here. And if there is something that you are essentially missing from the Trino query engine, please do open an issue and let us know that's something that you're really wanting to get. But yeah, and anything Ryan or Sam or Tom or Cole, anybody have any other things they'd like to add in terms of what we've been doing lately and the kind of overlap here?
Yeah, I think it's just worth emphasizing that like the Iceberg connector if it isn't the most active area of development in Trino, it's right up there.
Yeah.
So there's new stuff coming out all the time. Keep an eye on it, right? Like, we're gonna get more cool things in the next coming weeks and months. And you said already, keep updated, but like, seriously, like, you will get performance improvements, new features, basically every release in Trino. So it'll be rewarding to stay up to date on that, because it's improving all the time.
Yeah.
Absolutely.
And one final kind of thing to put on with that too is like, now with all these changes too, like, we used to kind of have to debate whether we would recommend somebody who's brand new coming to Trino whether they should use Hive or Iceberg. I think like we're actually at a point now where we can pretty much just say, if you want to use Trino, you can just use Iceberg, and you don't have to worry about, like, you shouldn't have to like worry about all the stuff that could be missing from Hive that you like that isn't an Iceberg yet. We're pretty much at a place now where that's like, that could be your primary storage. So,
well, and more is also coming, right? The rep catalog support that's up and coming is really going to be powerful. Like, I'm excited because you'll be able to connect to Tabular, and Tabular takes care of things like optimize and expire snapshots and remove orphan files and all that sort of in the background, so you don't have to think about that. You don't have to think, hey, when was the last time I like compacted my data files? You know, you kind of want something monitoring your commits and watching that for you. So like, I'm really excited about how that's going to allow us to work together.
Totally.
Yeah, and I think on that is, I talked about Galaxy. Our SaaS solution is, we made the decision that default to Iceberg for everything. So if you're just using Galaxy, you start creating tables, it's all Iceberg. So that's how confident we are. So that's good news.
Yeah, totally. All right. Well, with that, let's move on to the PR of the week. All right. Oops. And I removed it on accident.
It's gone.
Where'd it go? Okay. So this PR of the episode, we alluded to earlier in terms of this like super performance punch that we got to writing tables. And this is also another big deal when it comes to, when we talk about the merge feature and being able to do these super fast inserts on Iceberg. We want to be able to kind of do this kind of faster writes, right? And so this particular table writer is now per task, it's going to automatically detect what essentially the amount of data that's basically coming through a writer and scale that automatically. Right now, it kind of defaults to 1, but what this PR is attempting to do is basically trying to ultimately allow the ability to basically, if there's some skew potential or things like that, now you can say, okay, well, this one essentially worker or task is getting everything. Now we can split that out across multiple workers, across multiple tasks. And this is kind of getting into some of these like ideas of like, adaptive capabilities that we're bringing into Trino, where now we'll be able to scale up the tasks automatically. So this is super exciting and fun. And on average, we are seeing a 6x speed up for some initial results that we did with, various tests. And so it's really going to be interesting to see what this looks like in practice. This isn't just for Iceberg either. This is for everything in Trino. So that is, just basically super exciting. And wanted to thank Wara for, bringing this in, and everybody who was doing the basically the what am I trying to say? The review for this. Anyways, anything on this, Cole? Yeah, I was gonna say, do you want to?
Yeah,
give any more
it's not
context?
everything in Trino. It only impacts, I think, Hive, Delta Lake, and Iceberg.
Okay. I thought this was. Okay. Yeah, of course, because this is like thinking through anything that is talking to like a distributed file store, that kind of thing.
Yeah, so it won't be everywhere, but it'll be for those 3 things. But
what would this not be?
It's Iceberg.
Would it not make sense for other distributed systems, or is that possible, or are you aware?
I think there's more to come. Like that PR, I think it's an improvement. It's not working incredibly well with partitioned tables.
Okay.
And that's like more down the line. And we may see, follow-up work related to that. But that's at least where it is right now. And that's going to impact, a broad variety of use cases, because I think a lot of people are just using Hive Delta or Iceberg. We're recommending Iceberg. So
Gotcha. Real quick, we've had a couple chats come in that I missed. So first, I want to bring up Manfred is apparently watching us. We kicked him out today, and so he's keeping his eye on me and Cole, making sure that we're behaving well on the show. And then Damon, as always, our longtime fan. Thanks for always joining these and hanging out here. Manfred is ready for the demo. And one last thing, Brandon, not sure for which Brandon this is, but I for one am excited about the future of Iceberg, and we are all super excited about the future of Iceberg. So with that, let's hop into an Iceberg and Trino demo. I couldn't find it, and I was like, "Oh man, I bet." I was like, "Is everybody thinking that I'm having a stroke, or that I just like?" Okay. Anyways, let's hop real fast into the demo of the episode. I also said I think the concept of the episode before, or concept of the week. I'm still so used to saying week than anything else. So. This is coming from the Trino Getting Started repo. I already pulled up this repository and go into basically the Iceberg and the Trino Iceberg MinIO demo. And then you'll just run docker compose up -d. You have to have Docker installed. It's super easy if you're on Mac and Windows. If you're on Linux, I hope you know how to set that up. Yeah, it's not horrible. I've done it once before myself, but it's just not like a click on a DMG or something like that. So, but not the worst thing in the world either. But yeah, set up that and then pull up, go to this directory, and then you'll put docker compose up D. Now, basically what that does is it pulls up MinIO in the background. So let's actually can pull up MinIO real fast here. Oops. And we'll log in there just to kind of, I always like to, when we're doing these data lake ones, I like to, it's because I went to there we go. Okay. So basically MinIO is just going to be showing us the actual data layer of our data lake. And let's go ahead and also, we also have Trino running in the background just for showing it. So we have Trino right there. Okay. And so once those are running, we can actually start going through and setting this up. Now, I have let's do a show catalogs. You can actually go in to see the catalog setup that I have in this setup here. But basically, I have Hive Iceberg set up as catalogs, as also a couple of our freebie generated catalogs there. And so basically, we'll use the Iceberg throughout this whole one, but we also have Hive for other, if you want to play around with like going between the two. So first thing we got to do is we got to create a schema, and we're going to use the schema to actually point us to a particular location inside MinIO. So inside MinIO, let's go ahead and create that location. I always like using this logging example that is kind of the default example on Iceberg, unless you guys changed it. But yeah, so we just create a bucket logging, and we're going to point our schema there. We'll run that. And then we're going to, and actually, can you all see that? Let me see if I can zoom in just a little bit there. Okay. And so now we're going to do the create table. And this is going to be pretty much the same thing that we created in the last episode in Trino Community Broadcast. The only difference here is the default actually here is actually 2, but I wanted to add this just for clarity, that this is a new property that you can specify. And if you are using like format version 1, you could specify that there. But we highly recommend just not putting anything or just specifying 2. That keeps you on the latest version of the Iceberg spec. So we'll go ahead and create that. And what this is going to do is create four columns: level, event, message, call stack. And you can kind of look at the different types there. And we're going to be partitioning using a day level partition on event time call stack. And so this was already one of the big differences that we pointed out, is that, you know, you're not having this actually gets kind of internally managed inside of the Iceberg format for you, and you're not having to really think through like putting the event a secondary event time column or anything on the last column and all that kind of stuff. So that's already one cool thing from, you know, the Hive format that you don't have to do. So let's go ahead and insert some data in here. We're going to insert just 2 records for right now. And let's go ahead and select and make sure that those got in there. Sure enough, we have some data sitting in there now. And I'd like to first point out, now that we talk about, like, you know, the partitioning level and doing our partition migrations, we currently have one partition that's at the day level. So it's these 2 different rows are coming in at different times, different hours, but they are at the same day. So that is just one single partition that we have here. And so now we can actually run this partition migration. So this is alter table, Iceberg logging logs, and we're going to set the property partitioning now to kill the level part of that partition. And we're just going to actually just split it into just hour at the event time. So now anything that we push in now should go to that partition. So we'll go ahead and insert some new data here. So this is the 3rd message, 4th message, and 5th message. It's kind of how I'm uniquely identifying these, since we don't have any kind of key that we're using. And let's go ahead and pull from that table again. We see 5 different messages that get pulled back. Let's go ahead and look at those partitions now. So now we actually have the event time day, this initial partition that we had at the day level, that has the 2 initial records that we pushed. And now we're gonna, the 3 different records that we pushed, they differ. 2 are on the same hour. So 2 of these are in 3 o'clock, 3:55 specifically, and then this one is 4:55. So the 4:55 gets set at a particular hour down here, and the other one is on this one. So we have 3 different partitions now moving forward, which is pretty cool. So now if we actually do a query like this, where we're going to say, I want to get anything that is less than 4:55, essentially we want to cut out one of the particular cases. It doesn't have to actually scan the 4:55 timestamp. It can actually scan any time before that. So it's going to only touch the day level at 4:1, and it's only going to touch the hour one that has specifically falls inside that time range. So we correctly get only 4 messages back, as we aren't getting the last one, but we only talked to 2 partitions. We didn't have to scan every single one, which is pretty cool. So let's look at the. I'm not sure actually. Oh yeah. And I was just going to look at we also have the concept of snapshots. I want to point that out there. So each different write that we've done so far has done a different snapshot for each kind of insert. So we have the create, and then we have the 2 inserts for those snapshots. And now let's run an update. So we're going to basically say anywhere on the logs that has the warn level. So again, let's look at our logs table one last time. So we have 2 warn rows. We're going to add well, hello there message to the call stack for that update. It's a very important update to run on those warn levels. And so if we look at that, this is now showcasing update. And there it is. Well, hello there fits inside the call stack for only warn levels. So So that's showcasing update. I forgot to put in delete here, but delete also works. And let's go ahead and look at the snapshots now. So interesting here is that the update shows up as an overwrite. So, sorry, that's not interesting. And what we want to do real fast is let's see if we can look at the snapshot before that. So this is that time traveling. The old way that we did in the previous episode was this format here, where it says Iceberg logging logs, and then this at notation, and then you would specify the snapshot ID here. Actually, let me just make this, well, here, doesn't matter. But here now we use select all from Iceberg logging logs. And now instead of having this kind of hacky thing that you have to do with the table, you use SQL, you say for version as of, and then you'll specify the actual snapshot ID. And now what we should see is what the table looked like before the actual update happened. So we don't see the whale hello there in the two warning rows. And then now one final thing we'll show is the merge. So for this, I tried to get like one where I didn't have to fully create a table. I wasn't able to get that to work. So I'm going to create a source table. We'll just call it Iceberg logging and just call it source. And it's just going to have 3 of the 4 columns that we have in the message or in the logs table. And then we're going to insert basically kind of a mask. If you think about it like this is kind of like just values that we want to essentially mask with the existing tables. So we'll insert those. Oh, what did I do?
The string has single quotes in it. So
yeah. Thank you. I'm just going to take those out. And what did I do that anywhere else? No. Okay.
Messed up your grammar though.
Okay. Yeah. Here, I think when I run this again, it'll fix it. This is just what dbeaver does. It keeps.
That's gonna bug me.
Yeah. Okay. There we go. All right. So I'll fix the grammar before I post this onto the show notes. Okay. So we inserted 3 of these rows to kind of act as the kind of mask. And so what we're going to do here in this merge, we're going to merge into the logs as our target table. And then we say, so merge into logs as the target. So I'll call that T, using Iceberg logging source as S on S message equals T message. That's kind of my unofficial way to associate these rows together. And then here are going to be 2 different things that we're going to run. For these 3, whenever the source is essentially level error, then we're going to go ahead and delete that row. If it matches and basically when matched is on this particular predicate, the message equals message. So when you match that and the source is equal error, we're going to delete that row. When it's matched and then we and no other criteria is specified. Basically, when we have any other match, then we're going to set message equal to, we're going to basically concatenate the message with updated. And then we're going to also concatenate the call stacks from the source to the call stack of target. So let's go ahead and run that merge. And now let's take a look at what happened. So now we're saying one of these errors went away, and that was actually the 3 message one, because we had a match on the message and it was an error from the source. So that got deleted. And then we also set update on the message itself. So we updated both of these warn stacks, and that's because we matched on 4 and 5 here, 4 and 5 message. So, and then we happen to also add into the, what is it? Here it is. This should show up as well. This should show up. So those 2 also got added to the call stack. And finally, when you look at the merge, those actually end up being yet another overwrite that we see in the snapshot. So that is the demo. And essentially, that is the show as well. Ryan, Sam, thank you so much for joining us today. I'm super excited for the future of both Iceberg and Trino with Iceberg together. I really think, in terms of making flexibility, the options that people have in terms of, that all of our users have to find solutions to all of these problems that we've discussed today, makes it super flexible and super capable for people to run these different setups and not have to be kind of locked into any format, any vendor specific thing, any particular query engine. Like, it just really opens up a lot of the freedom here. So I'm really excited about this. What all do you want to share to kind of before we hop off, to kind of how people can get involved, where to get started with Iceberg and that kind of thing?
Yeah. So first, thanks for inviting us onto the show, Brian. It was fun, and thanks for the demo too. I can't wait to try those things out. It looks really cool. DML and Trino's. I'm excited to try that out. But anyone can join by going to the Iceberg community page. So it's just iceberg.apache.org/join, and you'll get all the info. We have Slack.
Nice.
There's the dev list if you want to, if you want alerts on the latest things that are happening in Iceberg. So, and you can reach out to me too, right? We post a lot of blog posts on tabular.io. So please check out there. We have a lot of Iceberg content there. And feel free to reach out for anything, any questions or thoughts.
Cool. Ryan, any parting thoughts?
I'm really excited about all of these new features in Trino. We should do a bunch of joint blog posts on what you can do with merge into and that sort of thing. Yeah. These are really powerful things. At Netflix we had this pattern where people would read data, take new data, sort of join it together and munge it, and then write it out and overwrite everything. Read, union, overwrite. And I'm so excited about merge because it allows you to do that without manually expressing how you want this thing to run.
Yeah.
You say hey, if I've got a match, do this. If I don't have a match, insert. And it's so much easier and straightforward. And not only that, it's more efficient for Trino to run the query because it only needs to modify the data files that have data that changed.
Yep.
So I'm super excited about this. Let's write some blog posts or something to.
Let's do it.
Yeah, highlight these amazing features. So,
yeah, we're definitely doing it, and hopefully we can see you both out at Trino Summit. So reminder for everybody else too, we have Trino Summit coming up in November. So if you haven't signed up, we'll be adding that into the show notes as well. Cole, Tom, did I forget anything?
Well, no, kind of touching what Ryan was talking about is really, I'm going to a Coalesce, DBT's Coalesce. That's our conference next month, and really open up that product completely for Trino and Iceberg. So I think some of the stuff we'll be talking about is all three together. So totally. I know it sounds really dorky, but I was super excited about merge. So
yep.
And
weren't we all?
Yeah, I need a tattoo or a shirt or something like that.
Yeah, merge made it. Okay, all. Well, thank you so much, and we'll see you all in the next Trino Community Broadcast episode.
Music for the show is from the Mega Man 6 gameplay album by Krzysztof Sławikowski. Don't forget to give us a star on the Trino repository at github.com/TrinoDB/Trino. And for more information on future shows and to find show notes, check out trino.io/broadcast.